So this video is integrated one. It is the semester 2 final review. This is classwork number 3. It's going to be the chapter 5 portion of classwork number 3. So this is on sequences. Remember, we have arithmetic and geometric sequences. And arithmetic sequence, let me make this a little bolder, is when you are adding. So arithmetic is when you're adding or subtracting the same number over and over again. And the graph for this is going to be linear. Geometric is the other one. And this is when you are multiplying or dividing. We usually want to write it as a multiply. And this is exponential. So in this first example, I am going to count how many values we have here, how many dots we have here. So at the beginning, we have 1. At 1 minute, we have 5. At 2 minutes, we have 9. So what we're doing is we are adding 4. So since we're adding 4, that means it's arithmetic. We call a common difference what we're adding. So D is going to be 4 because we're adding 4. And what we do want to pay attention to is whether this first number here is our first term or our 0 term. So when it says at the beginning, this is our 0. So this is really saying f of 0 is 1. Here, this is when it's 1 minute. That's saying f of 1 is 5. So my first term is 5. My 0 term is 1. My second term is 9. So describe the pattern that you see in the sequence of figures above. So we are adding 4 each time. 4 dots each time. Assuming the sequence continues in the same way, how many dots are there at 3 minutes? So we had 1 and 5 and 9. So the next one would be our third one. So if I add 4 to that, I am going to get 13. So 13 dots. Now that idea of taking the last term and adding on to it to get the next term, that idea is a recursive idea. To figure out how many dots there are at 100 minutes, it might be helpful to figure out an equation or something that we're doing. So what I'm going to write is if I want to find f of 100, we are starting with 1 dot and we are going to be adding 4. We add 4 once to get to my first term, twice to get to my second term. So we're going to add it 100 times to get to my 100th term, or 100 minutes in this case. So when I work that out, I'm going to get 401 dots. Now, if they want to know t minutes, I'm going to do f of t is equal to 1 because that's my 0 term. That's what we're starting with. And we're adding 4 t times, and that would be our equation. On this next one, when I'm looking at this one at the beginning, so this is going to be my 0, we have 3 terms. So f of 0 is 3. At 1 minute, we have 6 terms. So f of 1 is 6. At 2 minutes, we have 12 terms. So f of 2 is 12. At 3 minutes, let's see, we've got 24 because we have 3 sets of 8. So it's going to be 24. So f of 3 is 24. So you might notice that every time we are timesing by 2. Timesing by 2, timesing by 2. So if I times this one by 2, I am going to end up with 48 here. And I have 3 sets of 16, which is 48. So f of 4 is 48. So this one is going to be geometric. So it says describe the pattern that you see in the sequences and the sequence of figures above. We are multiplying by 2 each time. And let me just do this up here. When I said I was adding, that meant that this is arithmetic. And this one here, when I am multiplying, that means that this is geometric. Assuming the sequence continues in the same way, how many dots are there at 5 minutes? So we know at 4 minutes, it was 48. So I'm going to multiply that by 2, and I'm going to get 96 dots at 5 minutes. So again, that was a recursive idea. I'm taking the one before the one I want and timesing by 2. So on C and D, they want us to write a recursive and write an explicit. So for a recursive, the first thing I want to do is I want to know where are we starting. So I'm going to say f of 0 is 3. So we know that we're starting at 3. And then f of t, because they asked us to use t, is equal to the term before that, which is going to be f of t minus 1. So that's like over here when I use this 48, this was my 4th term to find my 5th term. So this is the term in front of my t term. And I'm going to times it by 2. Write an explicit formula to describe how many dots there are. So explicit formula, I should be able to get any single term I want just by plugging in that term number. So in this case, we want to start with our 0. Our 0 is 3. What are we doing? We are timesing by 2 to the power t. That is our explicit equation. On number 3, for each of the following tables, find the missing terms and write the explicit and recursive equations for each. So in this situation, they are telling us that it is arithmetic. Okay, so these are all going to be arithmetic here. And we want to find the missing term. So basically, I'm starting with 5. Let me not get a highlighter, sorry. I am starting with 5. I'm adding something to 5. I'm adding that something twice to get to an 11. So in this case, if I was to solve this equation, if I was to solve 5 plus 2d is equal to 11, I am going to get 2d is equal to 6. So d is equal to 3. So that means I'm adding 3 each time. So if I'm adding 3, that means this is going to be an 8. If I'm adding 3. Another way to have worked out that same problem is if I was to average 5 and 11 together and divide by 2. So I add them up, divide by 2, I get 16 over 2, which is 8. That also would have given me that middle term. This method right here is called arithmetic means. Okay, so either way. Now they do want a recursive and they want an explicit. So my recursive one, I'm going to put R for recursive. I'm going to start with f of 1. F of 1 is equal to 5. And then that means f of, I'll use x because these are x's here. F of x is going to equal f of x minus 1. That's always what you're going to do with recursive. It's always 1 less. And then what are we doing? We're adding 3. Our explicit equation, I'll put an E, is going to be f of x is equal to. Now, one way is to go back and find our 0. Okay, so if I go back and find our 0 and we're adding 3, going backwards, I'm going to subtract 3, so I'm going to get a 2. So I'm going to start with 2. I'm going to add 3 x times. Another way to do it is if I'm going to start with my 1, I could have also written it as f of x is equal to 5, and I'm adding 3, but if I'm starting with my first term, this isn't an x, it's going to be x minus 1. Both of these are the same. Most likely you'll see the answer as the purple if it is a multiple choice. On the next one, again, this is arithmetic. So if I'm doing this, what we can do, I'm going to do it 2 ways. I can take 18. This one's going to be 18 plus d. This is going to be 18 plus 2d, 18 plus 3d. And this is going to be 18 plus 4d, which is going to equal 110. I'm sorry, equal negative 10. So if I solve that problem, okay, so if I go 18 plus 4d equals a negative 10, I'm going to minus 8. I'm going to get 4d, sorry, minus 18. I'm going to get 4d is equal to a negative 28. I'm going to divide by 4 and I get a negative 7. So I'm subtracting 7 every time. Okay, so if I'm subtracting 7, that means I am going to get an 11. When I subtract 7 again, I get a 4. When I subtract 7 again, I get a negative 3. And when I subtract 7 again, I get a negative 10. Another way to have done that is to do the arithmetic means. Take 18 plus a negative 10 divided by 2. That's going to be 8 divided by 2, which is 4. That would have given me this one right here in the middle. Okay, it would have found the middle one. Then I could have gone through the same process and did that with 18 and 4 to get my 11. So then I could have taken 18, 18 plus 4 divided by 2. So that's going to be 22 divided by 2, which is an 11. And you see that I got an 11 here. And do the same on the other part. So I could have taken 4 and negative 10. 4 and negative 10, added them up, divided by 2. That's going to be a negative 6 divided by 2, which is a negative 3. And that's what I got here. So the way I did it in pink will give me what I'm adding and subtracting. The way I did it in blue will give me the actual value. Both methods work. So now I need to write a recursive. So for the recursive, again, I need to see where I'm starting. F of 1 is 18. And then f of x is going to equal f of x minus 1. And then what am I doing each time? I'm minusing 7. Then my explicit one, if I go back and find my 0, so if I'm minusing 7, I'm going to go backwards by adding 7, and that's going to give me a 25. So f of x is equal to 25 minus 7x. Okay, this is always my 0. This is what I'm adding and subtracting. If I wanted to start with my 1, I could have done f of x is equal to, and start with the 18. I am minusing 7 still, but since I start with my first term, I'm going to be off by 1. So this is an x minus 1. But again, it'd probably be in the purple form. Okay, the next one. In this case, I am going to this is going to be 12 plus d, 12 plus 2d, 12 plus 3d, 12 plus 4d, 12 plus 5d, and this last one is 12 plus 6d, and that's going to equal a negative 6. So I am going to work out 12 plus 6D equals -6. I'm going to subtract 6 from both sides. Sorry, 12 from both sides. I get a -18. Divide by 6 and I get a -3. So I'm minusing 3. So if I'm minusing 3, I'm going to get a 9, a 6, a 3, a 0, a -3, and a -6. Now, I could also have done my arithmetic means by taking 12 plus a -6 and averaging that. So I'm going to get a 6 divided by 2, which is a 3. And you see I got a 3 right here. Now, in this case, I'm not going to be able to find the 1 in the middle by doing that. So I would have to figure out what I am adding each time. So on a problem like this, I personally would probably recommend doing it the pink way. So you find out what it is and you just subtract the whole way. So recursive. Recursive f of 1 is going to be 12. And f of x is going to be always f of x minus 1. And then what am I doing? I'm minusing 3. Now for my explicit, if I go back and find my 0, I'm minusing 3. So I'm going to add 3. I'm going to have 15. So this is going to be f of x is equal to my 0, which is 15. And then what am I doing? I'm minusing 3 x times. Again, if I wanted to start with my 1, that would have been f of x is equal to my first term, which is 12. I'm still minusing 3, but this time I'm going to minus it x minus 1. On number 4, these ones are geometric. So in this situation, we are multiplying. So one way to go about doing this, if this is my 3, it's my first term, this is going to be 3 times r. This is going to be 3 times r squared is equal to 12. So I'm going to work this out. 3r squared equals 12. I'm going to divide by 3. I get 4. And I am going to take the square root of that. Now, when I take the square root of that, that could be a positive or a -2. So I could be multiplying by 2, or I could be dividing by 2. I mean, sorry, multiplying by 2 or multiplying by a -2. So in this case, I could have a positive 6 if I multiply by a positive 2, or this could have been a -6. So I'm going to put a plus or minus. Now, in this case, it only asked us to find the missing terms. Okay. So, and then here it says, is the missing term that you identify the only answer? Why or why not? So there are 2 answers. When you square root, a positive and a negative. So we got more than one answer. In the next one, they want us to find the missing term here. So for this one, what I'm going to do is I'm going to go through the same process. Okay, so I'm starting with my 7. This is 7 times r, 7 times r squared, 7 times r to the 3rd is equal to 875. So I'm going to do 7r to the 3rd is equal to 875. I'm going to divide both sides by 7. So let me see, 875 divided by 7 is 125. And then I'm going to take the cube root of that. Now, when I take the cube root of anything, I'm only going to get one answer. Any odd root, I get one answer. I don't get a positive and a negative. So in this situation, I'm going to get r is equal to 5, only 5. Because if it was a -5, a negative times a negative times a negative would have given me a negative 125. So the only way to get a positive 125 is to have them all be positive. So there's only one answer. So are the missing terms that you identified the only answer? Why or why not? Yes, they are the only answers you only get one answer when you cube root. You get the whatever sign you start with. Now, I didn't actually get the answers here, so let me put our answers in here. So this is 5, so this is going to be a 35, and 35 times 5 is a 175, and then 175 times 5 is 875. So in this next one, I have 6. I have 6r squared, 6r cubed, 6r to the 4th is equal to 96. Now, when I take any even root, I am going to get 2 answers. So when I'm working this out, I'm going to divide both sides by 6. So let me just write that here. And when I divide by 6, 96 divided by 6 is 16. I am going to take the 4th root. I'm going to take the 4th root of both sides. Now, when I take a 4th root, I get a positive and I get a negative, any even root. And the 4th root of 16 is going to be a positive and a negative 2. Now, what that means is every other is going to be a plus minus. So for example, if I was just doing it by the positive 2, this would be a 12, this would be a 24, this would be a 48, and then I get my 96. But when I am multiplying it by the negative, 6 times a negative 12 is 6 times a negative 2 is a negative 12. So this is going to be a positive and a negative. Okay, the positive from the original situation and now negative. Now I'm timesing by a negative. So negative 12 times a negative 2 is a positive 24. So this is not going to be a plus minus. 24 times a negative is going to be a negative 48. So this is going to be a plus minus. So every other is going to be a plus minus. And that's the end of this video. I'm going to do a video on the chapter 6 portion next.